Hello, this is the section 4.1 lesson. This section is titled, What is Statistics? Now this section contains a lot of definitions that I'm not going to talk about in this lesson. We'll let you read those on your own. What I want to cover in this short lesson is the big ideas. What are we doing in statistics, and what ideas are we going to introduce in this section? So we start off this section with a simple scenario to try to illustrate some of the ideas that we're trying to do here. So suppose a grocery store manager is studying ways to improve customer satisfaction. And particularly this manager is interested in the amount of time that customers spend waiting in line. So some questions the manager might ask are, number one, what's the expected wait time? Number two, what's the probability that the wait time of a randomly selected customer is greater than 10 minutes? Number three, how much variation is there in wait time? In other words, does everyone wait about the same amount of time, or do some people wait a long time and some people wait very little time? So these are three questions that seem reasonable to ask about this scenario. Okay. So starting on the first day of class, we introduced this idea of there being two worlds. There's the real world, and then there's the math world. So far, throughout the first three chapters of this book, we've spent most of our time working over here in the math world, developing mathematical ideas that we can use to answer questions over here in the real world. Of course, we live here in the real world. We ask questions in the real world. We want answers in the real world, but we use math world ideas to try to answer those questions. So in this real world scenario, we've got our three questions. What's the expected wait time? What's the probability the wait time is greater than 10 minutes? And what's the variation? Well, let's go over here to the math world for a second and use some mathematical ideas. So first of all, let's define a random variable x to equal the wait time of a customer. Okay, that's a very mathematical idea. Random variable is a very abstract mathematical idea. Well, now in terms of this mathematical idea, we can restate our real world questions as, number one, what's the expected value of x? Number two, what's the probability that x is greater than 10? Number three, what's the variance of x? So we see here that we can take our real world questions and state them as three equivalent math world questions. Okay. Well, now working over here in the math world, we know how to calculate these types of values, but in order to calculate those, we need to know the parameters and the appropriate distributions of our random variable. So we need to know the distribution and the appropriate parameters of x in order to calculate these three values. So we want to know, for instance, does x have a normal distribution? Does x have an exponential distribution? Does it have a binomial distribution? What type of distribution does it have? And then once we know the appropriate type of distribution, it has associated parameters. For instance, an exponential distribution has a parameter lambda. Normal distribution has parameters mu and sigma. Uniform distribution has parameters a and b. And so if we know that distribution, the appropriate parameters of x, then we can very easily calculate these values, and we'll be all done. So next question is, well, how do we know the distribution and the appropriate parameters of x? Well, we need to go back over here to the real world and collect some wait times of some actual customers. So what we need to do is stand there and observe some different customers and record how much time did they actually spend waiting in line. So maybe we'll observe one customer and he waits 5 minutes, and we observe a next customer and he waits 30 seconds. We observe another customer and he waits 1 minute 50 seconds or something like that. Well, in terms of our random variable over here in the math world, these wait times that we actually observed are called observed values of this random variable x. We've used this term many times before. Or in simpler terms, these observed values are simply called data. Okay. So we've got our real world construct over here, this random variable. We need to know its distribution and parameters, so we're going to have to go over here to the real world, collect some observed values of x, which we also call data. And then in chapter 4, we're going to start talking about how we can use that data to approximate the distribution and the appropriate parameters of x. So this scenario suggests or leads to a couple of definitions. Number one, data or observed values of a random variable. Right? We just stated that definition. Second definition is the field of statistics is a collection of methods for estimating distributions and parameters of random variables through the collection and analysis of data. So that's what statistics is really all about from kind of an abstract mathematical world perspective. In statistics, we're trying to estimate distributions and parameters of random variables. And we're going to do it by going to the real world, collecting data, which we also call observed values of the random variable, and then analyze it, and then go from there. So these two definitions here are very, very important. They form kind of the foundation of everything we do in this book. These definitions really connect the ideas of probability and random variables to these ideas of statistics. So again, these definitions are kind of from a math world perspective. Here in a bit we'll give a little more practical real world perspective definitions of these terms. But before we give those definitions, let's make an observation. Okay? So thinking about here in the real world, we've got these three questions. What's the expected wait time? What's the probability? And then what's the variation? Okay? So those three questions are asked about the large group of all customers. Right? We really want to know the expected wait time of all customers. We want to know the variation of all customers. However, when we collect wait times of customers, we're not going to be able to stand there and observe every single customer that comes through a checkout line at this grocery store. We're only going to be able to observe a small subset of all these customers. Maybe we're going to go out and observe 30 customers or 50 customers or 100 customers. Well, that's not all the customers. That's just a small subset. So our data are going to be collected from a small subset of customers. So this this observation leads to our next set of definitions. Number one here, the population is the set of all objects of interest in a statistical study. And then a sample is a subset of the population. So here's a simple illustration of this. The population is the large set of all objects that we're interested in. Sample is a small subset of that population. Now, population doesn't necessarily have to be a group of people. In this case, our population is all customers, but population is really a generic term for everything we're interested in a particular statistical study. And then a sample is just a small subset of that population. Okay. So now, with these terms, population and sample defined, we can go back and restate our definition of data and statistics in a little more practical, real-world perspective. So data are information that has been collected. Data don't necessarily have to be numbers. They can be numbers. They often are, but they don't have to be numbers. And in section 4.1, you'll read a little bit more about different types of data, data that don't have to be numbers, and so on and so forth. And then the field of statistics is a collection of methods for drawing conclusions about a population by collecting and analyzing data from a sample. So from a practical perspective, what we're trying to do in statistics is to draw a conclusion about a large population. And we're going to do that by collecting and analyzing data from a sample. So a real simple illustration of this idea, here's our large population. We want to know something about that large population, but we may not be able to get information from every single member of that population because our population might be several thousand or million. So we're never going to know exactly what we want to know about this population. Instead, we're going to get some information from a small sample, which is hopefully relatively easy to do. And then we're going to use information from that sample to try to draw some conclusions about our population. So that's really what we're doing in statistics from a practical perspective. We want to know something about a large population, but that's maybe very difficult, if not impossible, to do. So instead, we're going to get information from a sample. We're going to analyze that information and try to draw some conclusions about our large population. Okay. Now next, a couple more definitions that go along with population and sample. Number one, a parameter is a number calculated using information from every single member of a population. And then a statistic is a number calculated using information from a sample. So if I go out and I get information from every single member of my population, and then I calculate something like a proportion or a mean, that number would be a parameter. However, if I use only information from a sample, then that number I calculate is a statistic. So a little simple illustration here. Population and parameter go together, sample and statistic go together. What I want to know is my population parameter, but I may not be able to know that exactly. So instead I calculate a sample statistic, and then I try to draw some conclusions about the value of my population parameter. So that's pretty much the main points of section 4.1, or at least the main points that I wanted to cover in this lesson. The rest of section 4.1 will let you read from the textbook, but basically there's two big ideas. Number one, types of data. Again, going back to this idea that not all data have to be numbers. And then number two, some basic methods for collecting data.